Okay, here we are in Unit 7. This is the transition unit of the 4 different approaches to forest, climate, and carbon adaptation that we're testing here. With this treatment, we knew that we wanted to get away from overwhelming aspen dominance. What we're experimenting with here is the function, the composition, the future performance of a forest that is life after aspen. So what we were starting with here was the most diverse of the treatment units available for this experiment. We had more codominance and understory species. We had a greater diversity of topographic positions, soil types, hydrologic regimes. So this one, to work with that site, it made the most sense to really transition it away from aspen and work with that diversity of other things and other places that are present on this treatment unit. And behind me are more species than I'll name, but they're the ones you've thought about already: oaks, maples, beech, but there's also hemlock, basswood, yellow birch, jack pine, red pine, white pine. All of those things are found on this unit. And the careful operators just plucked out the aspen, except for a few places where removing all the aspen would have brought back aspen. A little bit of aspen residual basal area left there to maintain shading, with the idea that we're going to transition this forest away from an aspen-dominated system towards really an assemblage of a variety of climate winners. We've got those northern hardwood species here, most of which are poised to do okay or better. Basswood in particular, black cherry, these are climate winners that we're starting with here. I'd like to point out in this unit, this was the first of the 4 harvested. This was harvested in the spring on a year with an unusually heavy snowpack. So we had almost no ground disturbance, almost no mineral soil exposure. And we also have really advanced regeneration. You're looking at aspen suckers that are in the middle of their 3rd growing season post-harvest, and they're already 3-4 meters tall. Nonetheless, our forester, Dean, ensured in the cruise and the marking of this sale unit that we would retain sufficient basal area to shade out this aspen that comes back. We'll monitor it through time, of course, but what we expect to see is this aspen get fairly far along, but not before the tops of these residual accessory species shade them out. So we'll get away from aspen.
Hi everyone, my name is Chris Goff. I'm a forest ecologist here at the University of Michigan Biological Station, and I'm here to tell you a little bit about the Forest Accelerated Succession Experiment. This is an experiment that's been running since 2008 that involved the stem girdling of more than 6,700 aspen and birch, so early successional mature forest canopy trees here. Very common throughout the upper Midwest. They established during the phase of widespread clear-cut harvesting in the early 20th century. Much of that resulted in this broad establishment of aspen throughout the region. And our interest here, our scientific objective, was to understand how the maturation and eventually the senescence, the decline of that aspen and birch as they age out of the ecosystem, will affect the capacity of this forested ecosystem to sequester carbon. We've been doing that again for about a dozen years, and we've learned quite a lot about this ecosystem. The bottom line is that despite the loss of these aspen and birch trees, including this one here, which was stem girdled to remove the phloem tissue around the stem, which results in death, what we found was that when we did this, the remaining vegetation, the living healthy vegetation, really picked up the slack with respect to carbon sequestration. They grew more, even though this tree stopped growing, and the result was a maintenance of carbon sequestration, even though, again, about 40% of those canopy trees died. That was surprising to us, but also encouraging if our goal is to continue to cultivate forests that will sustain carbon sequestration into the future.